When most people picture an Ice Age giant, they imagine the woolly mammoth. But the mammoth was not the largest land animal of its time. This is a Pleistocene story stretching from hundreds of thousands to tens of thousands of years ago across Eurasia and South Asia. It's about Palaeoloxodon, namadicus, an elephant so immense that some scientists think it may have been the heaviest land mammal ever, while others argue those estimates rely on fragmentary, uncertain evidence. We'll explore its reinforced skull. The controversy around its size estimates range from well-documented dozen-ton individuals to far larger speculative reconstructions, and the remarkable tusks that helped inspire myths of the Cyclops. You'll see how humans encountered these giants and left marks of their struggle on bone. By the end of this story, you'll understand why Palaeoloxodon may have been the true heavyweight of the Ice Age, even if that title remains debated, and why comparison with the mammoth is only the beginning. Standing beside a mammoth might sound impressive, but Palaeoloxodon namadicus introduced a new scale of size. Scattered fossils hint at an elephant that could outweigh mammoths and even living African elephants by several tons. The challenge is that its bones survive only in pieces, so paleontologists must work from fragments, and that's why its maximum size remains hotly debated. The classic conservative estimate comes from an Indian specimen studied in detail. Scaling from its femur suggests a shoulder height of about 14.3 feet and a body mass near 14.3 tons. That already puts it well above the average African bull elephant, which today tops out at around 6.6 tons and beyond most mammoths, whose largest representatives reach 12 to 16.5 tons at most. By contrast, an early 19th century account describes a femur supposedly 20% larger. If that bone truly existed and the scaling math is correct, it would extend Palaeoloxodon's shoulder height to 17 feet and its body mass toward 24.2 tons. But that bone has not been located in modern collections, and researchers themselves stress it should be taken with caution, more a thought experiment than a fixed number. Paleontologists caution that these figures depend on single bones, and single bone extrapolations can swing wildly. A small error in measurement or in the scaling formula multiplies into several tons when stretched across a whole animal. That's why most headline numbers should be viewed as educated guesses, not precise blueprints. Adding to this, regional studies reveal variety within the genus itself. Work on specimens from Taiwan, for example, found animals averaging around 9.9 tons, with the heaviest scraping 14.9 tons, still colossal compared to modern elephants, but not the extreme giants once imagined. Together, these data points show Palaeoloxodon as one of the best candidates for the heaviest land mammal, depending on which specimen you base your estimate on. Its most striking features were not only its height and mass, but also its tusks. One partial tusk is estimated at roughly 12 feet long and over 265 pounds, if complete. That's as much weight as carrying 2 refrigerators angled forward from the skull. Such tusks demanded structural reinforcements. The species developed a large parieto-occipital crest at the back of the skull, anchoring powerful neck muscles. Those muscles counterbalance the tusk's immense pull and stabilize the head's bulk. Taken together, the tusks and skull reveal an animal specialized for both display and heavy use, as much about supporting its own anatomy as defending its survival. Picture the animal advancing across a floodplain, its shoulders rising higher than most nearby trees, bony crest bracing its head against tusks that could spear through dense brush. Every detail speaks to excess size and strength. Yet these same skull traits later had another legacy, not in biology, but in imagination, fueling stories that outlasted the animal itself. Why did ancient Greeks imagine one-eyed giants wandering the earth? One likely answer lies not in pure storytelling, but in the skulls of elephants unearthed around the Mediterranean. When a skull of Palaeoloxodon surfaced without tusks or flesh, it presented a startling feature, a massive hole in the center of the face. In life, that cavity anchored the trunk, but to someone unfamiliar with elephants, it could look exactly like a single eye socket. Combined with the surrounding bone ridges, the fossil resembled the face of a giant with one enormous eye. Accounts of Cyclops guarding caves may well trace back to such discoveries, where natural remains were read as evidence of monsters. The skull held other features just as striking. Rising behind that central opening stood a tall, parieto-occipital crest, exaggerated to an extent unknown in living elephants. This wasn't decoration, it served a mechanical purpose. Studies of comparative anatomy show that in Palaeoloxodon, the crest provided expanded surface area for splenius and other neck muscles. These were necessary adaptations to counterbalance tusks estimated at over 10 feet in length and weighing more than 220 pounds each. Without that reinforcement, the enormous pull at the front of the skull could have forced the head downward. The crest acted as the framework that allowed the animal to carry tusks larger than most Ice Age predators. Modern elephants show the contrast clearly. African and Asian species have broad skulls with moderate muscle attachment sites, strong enough for their tusks, but relatively compact. In Palaeoloxodon, the proportions were extreme. The skull arched like a helmet with the crest towering high to brace the load. Reconstructed tusks suggest a head package weighing as much as smaller ungulates of the same period. It was a functional adaptation first, but to ancient people stumbling across weathered skulls, the result looked alien, an oversized crown of bone above a gaping eye-like hole. Seen from that perspective, the origin of the Cyclops myth becomes understandable. Without living elephants in Greece during that period, there was no reference point. A bleached skull exposed in a hillside might easily become proof of giants instead of extinct animals. Cultural storytelling filled gaps in knowledge, and fossil elephants became monsters in oral tradition. Few natural objects could feel more convincing than a fossilized head feet long with only one cavernous opening staring back from the front. But the story of Palaeoloxodon is more than myth. Its anatomy, shaped by physics and survival, let it feed on vegetation inaccessible to smaller herbivores, strip bark and push through forests. The same adaptations that confused later observers ensured its dominance as one of the heaviest animals ever to walk on land. And while old bones may have inspired legends, fossilized skulls weren't the only way humans encountered these giants. At certain times and places, people faced them alive. What would it have meant when early humans confronted a straight-tusked elephant up close? The animal's height alone was staggering, its back rising well above the reach of an outstretched arm, tusks extending like immense ivory beams. For Neanderthals and early modern humans, this was more than spectacle. Such an encounter offered a massive source of food, bone and hide, yet it carried risks that could be fatal if it went wrong. Archaeology tells us these weren't only distant sightings. At certain places, bones and tools show the aftermath of direct interaction. In Central Europe, some of the clearest evidence comes from Leringen in Lower Saxony, Germany. Here, the skeleton of a straight-tusked elephant was uncovered, with a wooden spear shaft still lodged between its ribs. This detail is striking because it shows not only that Neanderthals approached elephants, but that they attacked them deliberately. The weapon's position implies an active hunt rather than scavenging preserved in the sediments of a Paleolithic landscape. At other European sites, such as Newmark Nord bones, also bear cut marks, marrow processing, and extensive disarticulation, suggesting intense exploitation. But in those cases, it is harder to separate hunting from systematic butchery of animals found dead. Far to the south in the Kashmir Valley of India, the Pampore site adds another line of evidence. Dated to between 300,000 and 400,000 years ago, proboscidean bones here carry stone tool cut marks and bone flakes used for marrow extraction. Researchers describe Pampore as the oldest unambiguous butchery site in India. While the material proves early humans systematically processed straight-tusked elephants, it does not alone prove they killed them. Even so, the scale of meat, marrow and hides obtained from such a carcass would have been beyond what any other Ice Age animal could provide. A single elephant could sustain a group for weeks, making the rewards of exploitation immense. But massive payoff came with massive danger. Palaeoloxodon namadicus required hundreds of pounds of vegetation daily, so it often moved along predictable routes to rivers, lakes, and stands of trees. That predictability made ambushing possible, but closing in on a creature with tusks longer than a person and a body mass exceeding any living elephant meant the margin for error was slim. For Neanderthals and early modern humans, success at these sites reflects both planning and teamwork. The The marks left on skeletons show coordinated activity with fire tools and repeated blows, a testament to how high the stakes were. Yet these human encounters were not the sole factor that determined the fate of Palaeoloxodon. Research points to three main pressures leading to extinction. First, climatic change during the late Pleistocene reduced dense forest and woodland habitats, replacing them with open steppe more suited to mammoths. Second, the enormous food requirements of such a giant made it highly sensitive to habitat loss. Third, archaeological sites across Europe and Asia confirm humans repeatedly exploited their carcasses, and in the case of Leringen, even hunted them outright. Estimates suggest Palaeoloxodon survived until sometime within the past 50,000 years, possibly lingering as late as 25,000 years ago, overlapping directly with modern humans. As cold phases favored mammoths in the open steppe, straight-tusked elephant populations dwindled. Human pressure likely accelerated that decline, leaving one of the mightiest land mammals in history consigned to memory. And while mammoths kept their image in art and story, another giant remained largely forgotten, a heavyweight whose legacy survives mostly in bone. In considering Ice Age giants, it is clear that Palaeoloxodon namadicus deserves recognition alongside the mammoth. It likely stood taller and heavier than most proboscideans, ranking among the largest land herbivores ever documented. But its exact scale is still debated. Conservative estimates are well supported, while the extreme upper figures remain speculative, based on fragmentary and sometimes unverified bones. Our picture of this elephant comes not from complete skeletons, but from careful reconstructions and ongoing debate. Its timeline is now better understood. It evolved from Palaeoloxodon reci, after dispersal out of Africa lived across Eurasia from the early Middle to late Pleistocene, and probably disappeared within the past 50,000 years, with some deposits perhaps as recent as 25,000. Imagine its vast skull with the central nasal opening and towering crest, both engineered for balance yet later misread as the face of a Cyclops. If this changed how you picture Ice Age giants, tell us in the comments: mammoth or straight-tusked elephant, which impresses you more?